This is the matter of very much important to use the equations of kinematics smartly. You may see while solving the questions of kinematics, students feel very much confused because of the language which equations involve. While using the equation of kinematics, one should have to follow a perfect strategy to solve the equations regarding the motion. If you talk about this application part, which we are going to discuss here, if we want to again recap, again review the equations which we have achieved in previous lectures, the three basic equations of kinematics are: the first equation v equal to u plus at, the second equation is s equal to ut plus half at square, and the third one equation is v square equal to u square plus twice s. Now equation seems very simple. These equations have been seen many of you most of the times, because while we study science, these are the basic three equations which explains all type of motion with constant accelerations. I am taking the first step towards using these equations in modified problems. If we talk about the first equation here, the first equation which is written here as v equal to u plus at. In this equation, if we try to find out the basic depth of this equation, then obviously we can say that here u is initial velocity of the particle. It means in the starting of motion, we see this velocity for that particular particle which is given to us to study about. We have the acceleration and we have to find velocity of the particle at some other time t. So obviously, using all the steps which I am following here, you can say that time used here is of future, because we are talking about the velocity 2 seconds after this time when I have been given velocity u. So here time is of future. Do not concentrate much here, but have the basic idea once. So this equation, which is basically of the form of v equal to u plus at, it is better to use it for the time of future. What I am doing here, I am just modifying this equation and I am writing it just in this way, that u is equal to v minus at. Now students may think that what I have done here, I just reformed this equation, I just brought this at part towards the v and write down u at the left hand side of this equation and v minus at at the right hand side. Generally, as you may know, generally we write values v, a, t which are known to us at the right hand side of any expression, and generally we take the unknown ones towards the left. Now here u is written as v minus at. If you consider this v, what is it? As we used previously that this velocity v is the final velocity, means we know what is the velocity of particle after a certain time or in future, you can say. Here v is the final velocity which we know, and we have to find velocity of the particle t time before. T time before means, you can say I am talking about the past. Here the time which is of past I have used here. I know the velocity v which the particle have at this time, and I want to find the velocity t time back. So obviously here unknown part is of past and known part is of future. Now we are at future, at this time and having the knowledge of v, and we are just getting value of velocity 2 seconds or 3 seconds back. So this equation gives the unknown velocity which was somewhere it passed. Now using these two equations in these two forms, you can achieve many conclusions. Just consider an example. In this example, I am giving just the simple theme. My question is, a particle is thrown vertically upward. What is its velocity 1 second before it reaches at its maximum height? Now, there is no initial velocity given in this question, but by this statement that particle reaches at its maximum height, indirectly we have been given the velocity at the time when it reaches its maximum height to be 0, because height will be maximum only if particle stops there and don't go further. So by this statement we can conclude here that velocity at its maximum height is 0. Now in this motion, as this motion is under the gravity, acceleration is g, which is 9.8 meter per second square vertically downward. So what we have to do, we have to find the velocity 1 second before it reaches at its maximum height, and this situation meets completely in synchronization with my second equation which I had written here as u equal to v minus at. Here in this question, if we talk about the solution, then I will take v to be equal to 0, acceleration to be 9.8 meter per second square vertically downward, and time as the 1 second which is of past. So what is the velocity? Velocity u can be achieved by using this equation where v is 0 minus acceleration is minus 9.8 meter per second square, because motion is vertically upward and acceleration is acting downward. Now the time which we have been given is 1 second. So this equation gives answer to this question just in a single step, and the answer is 9.8 meter per second moving vertically upward. Now you can see, if we did not exercise on this equation, then it would be a problem for us to solve this question using this equation, because no sufficient data for using this first equation has been given.